Okay, so you can see at the top of this page the steps that I took in order to create my function to resemble the one that was given. And so my final function was the f of x is equal to 2 sine parentheses 2x minus pi over 4 parentheses plus 3. So the first thing that I did in order to graph this function was I moved the parent function up by 3 to represent the plus 3 at the end. And then the second thing that I did was I moved the starting point of the first period of the sine function, which was at this point at 0, 3, to the right by pi over 8. Now, the third thing that I did was since I knew this period of the function was pi, I divided that by 4 to get the interval by which I will be labeling the x-axis. I got my interval to be pi over 4, so I added um, that to pi over 8 to get the next axis label to be 3 pi over 8. And I kept doing that with my other labels until I got the positive side of my x-axis to be pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, and then 9 pi over 8. And then I did the same thing with the negative sides. And so finally, I was able to graph my points. Since the altitude of my graph is 5, Fred will be at 3, which makes the starting y value, it makes the starting y value 3. And since it was shifted right pi over 8, the starting point is going to be at 8, 3. Given that the altitude of the graph is 5, the next interval is going to be at 3 pi over 8. And so that will give me the point to be 3 pi over 8, 5. And so then next the graph once again comes back down to Fred at 3. And the next x interval is at 5 pi over 8. So my next point was at 5 pi over 8, 3. Now my graph went down to the minimum at 1, with the next x interval being at 7 pi over 8. So my next point was at 7 pi over 8, 1. Finally, I was able to bring my graph back to Fred to complete the period. My next x interval was at 9 pi over 8, so my final point was at 9 pi over 8, 3. So the only thing that I had to do for change for part B was so I had to create a function whose asymptotes go through the extrema of my sine function that I found in part A. And so all that I did was change my sine graph to be a secant graph. And so this function gave me the h of x is equal to 2 secant parentheses 2x minus pi over 4 parentheses plus 3. And so first I found the domain by looking at the whole part of the secant curve on the top, which is curve number 2. And so I knew that the asymptotes of the function were at negative pi over 8 and 3 pi over 8. So the first part of my domain was from negative pi over 8 plus pi k, comma 3 pi over 8 plus pi k. I looked at the curve on the bottom and using those asymptotes, I got the second part of the domain to be 3 pi over 8 plus pi k, comma 7 pi over 4 plus pi k. The reason I'm adding pi k to all the values is because the domain represents it repeats itself every period, and for the period of this function is pi. So by adding pi to every asymptote, it accounts for every possible branch of the graph. This addition will be present in multiple pieces. Next, I got the range to be from negative infinity to 1, bracket union bracket 5 to infinity. The break in this graph accounts for the break in the maximum and the minimum of the graph. Next, looking at the asymptotes of curve 1 and the maximum of the curve and the asymptotes of the second curve and the minimum of that curve, I was able to determine that my graph increases from negative 5 pi over 8 plus pi k, comma, negative 3 pi over 8 plus pi k, union pi over 8 plus pi k, comma, 3 pi over 8 plus pi k. Using the same curves and asymptotes, I was able to get the areas where my graph is decreasing from negative 3 pi over 8 plus pi k, comma, negative pi over 8 plus pi k, union negative pi over 8 plus pi k, comma, pi over 8 plus pi k. Now, using the second curve and the first curve's intercepts, I was able to get my graph to be positive at negative pi over 8 plus pi k, comma, pi over 8 plus pi k, union negative 1.5999 plus pi k, comma, negative 0.758 plus pi k. And I got the second parts of my values just by looking at the graph that I graphed in Desmos. Now I was able to find the places where my graph was negative by looking at the first curve's asymptotes and then also the x-intercepts. I got my function to be negative at negative 5 pi over 8 plus pi k, negative 1.5999 plus pi k, union negative 0.758 plus pi k, comma, negative pi over 8 plus pi k. And then based on my sine function, I knew that the period of this one, this secant function was going to be pi. I was able to get my x-intercepts to be at negative 1.5999 plus pi k, comma, 0, and negative 0.758 plus pi k, 0. And once again, I got these by looking at Desmos. And so the next thing was the y-intercept. And so I got my y-intercept to be at 0, comma, 5.828. And once again, I just got that by looking at Desmos. I got the maximum graph by looking at the first curve. And by looking at that, I was able to get the maximum of my graph to be at pi over 8 plus pi k, comma, 5. And then I got my minimum of my graph by looking at the top middle curve's minimum point. So I got the minimum of my function to be at pi over 8 plus pi k, 5. And so going back to that maximum, it's actually at pi over 8 plus pi k, comma, 1. I said that wrong. And so now for my final part, I got the asymptotes. So I got the asymptotes to be at x is equal to 3 pi over 8 plus pi over 2k. The reason I'm adding pi over 2 is because in one period, there's two asymptotes that occur. So by splitting that period in half and adding that half of a period to every asymptote, it will account for all of them for every period.